Last week on Morse Code of Weather, we talked about all the different types of clouds and categorized them by low, mid, and high-level clouds, but there's a few very special types of clouds that are rather unusual that I wanted to go over this week and share with you in case you spot any of these. This was one that we saw in Glenburn on July 22nd. One of the best photos of a very strong cumulonimbus cloud, what we call a supercell thunderstorm, when you have these very fast rotating winds sculpting the clouds into this powerful storm. Now, ahead of these powerful cumulonimbus clouds or powerful thunderstorms that are usually severe, we can get shelf clouds. This was an example of that on June 24th in Kidder County when there was a shelf cloud out ahead of the thunderstorm. Now, shelf clouds, again, that little narrow band of clouds that forms ahead of the direction that the rain and thunderstorms are moving in, forms when you have a downdraft with the cold air moving in on the backside of the storm system. So with all that heavy rain, the cold air moves along the ground ahead of the storm, versus you have the updraft with warm air forced to rise up because of that colder air coming in along the ground. So as the warm, moist air is forced to rise up, it condenses and it forms that narrow stripe of the cloud, the shelf cloud, which usually speeds out ahead of the storm, and it can get pretty far out ahead of where the actual thunder, lightning, and rainfall is. Here's another example of a cool cloud type, mammatus clouds. June 29th in New Salem was this Sky Spy photo is when it was captured, and these pouch-like clouds form usually on the back side of large thunderstorm complexes. And they happen when cool air sinks on that back side of the thunderstorm to form those pockets. Again, the cool air condenses and you have those little sacks that fall down from your elevated clouds or your anvils of the thunderstorm. Now, this was a very interesting cloud type that actually confused me for a little bit. This was on June 19th in Steele. These clouds kind of look like UFOs or stacked pancakes, were actually a type of lenticular clouds. Now, they did not form in a way that you usually see lenticular clouds form. These formed on the outflow of thunderstorms. So when we had a complex of thunderstorms near Steele on June 19th, the outflow from those storms created enough turbulence to allow for these clouds to form. Now, normally with lenticular clouds, you see them near large mountains. And what happens is the air is forced to rise up the mountain and then condense into these clouds that have that smooth appearance to them because of the fast, stable air that is moving around them. And you can get them to be stacked in certain layers based on that turbulence a couple thousand feet up in the atmosphere. Now, here's a little graphic that explains that, where you have the air moving up and over the mountain with the lenticular clouds forming in regular intervals downstream of the mountain, and they can form in multiple layers up in the atmosphere. A special type of lenticular cloud on a mountain is a cap cloud. So right on top of the mountain, you can get those smooth cloud-like features because of the air that is forced to rise on top of the mountain. Now, on July 10th in Bismarck, we had a pileus cloud that was spotted just north of the city. This is a really interesting one that happens again with thunderstorms. When you have a really strong updraft with rising air, you can get that air to puncture into a stable, moist air that is flowing aloft. And once that updraft continues to grow, the air is pushed upwards, and that forms our little smooth cloud that you see up here on top of our growing thunderstorm, on top of our growing cumulus cloud. You have this little kind of UFO-shaped thing that's on top of the clouds. Again, that's a pileus cloud because of our rising updrafts. Now, another interesting cloud from this past summer was on July 20th in Crosby. This was a roll cloud, this narrow stripe of clouds that you see there in a pretty bright blue sky. And what happened here was you had two air masses that were colliding with warmer air to the south and cooler air coming in from the north. But they had similar moisture contents, both air masses. And the warm air rose on top of the cooler air, allowing for it to condense into this very linear-like appearance into a roll cloud. So there's a few very cool cloud types that I hope you learned a few lessons about. And back to you, Jody and Kevin.